Hello, we are at section 2.7, which is about combining functions. So you'll notice here that we can combine already existing functions by these processes or these operations, and we can get new functions. So when we get a new function, we want to talk about its domain. That's the first thing we do. So we will discuss how these new functions are explained or defined, and how we find the domain. So the first process with which we would find the function is using our usual operations of addition, subtraction, multiplication, and division. So we find the sums of functions, so we get a new function. So if f and g are two functions already existing, and if you add them, so we want a function f plus g, which will be a new function. So how do we define it? Well, if you call it the new function h, then we say h is the function f plus g. So h of x, if I want to find h of x, then h of x will be equal to f plus g of x. So how do I define this? So this new function is defined as f of x plus g of x. In other words, it is nothing but but adding the results of the function f and the function g. In the same way, f minus g of x will be, so I have shown you, written it in two different ways. One is by calling the function name h, and the other is just directly. So f minus g of x, we write it like this, and we say it is f of x minus g of x. Similarly, the product f into g of x will be equal to f of x times g of x. And then division, f over g of x will be f of x over g of x, and with g of x not equal to 0, because cannot have 0 in the denominator. So what about the domain? Well, the domain of the first three is found by finding the common domain of the functions f and g. So what about the quotient one? So for quotient one, it's a common domain of the two functions, but also now we have to check the values where g is 0, g becomes 0, and then throw those values. If they already exist in that common domain, we have to throw them away. So let's look at an example here. So I have given you two examples. In the first one, we have two rational functions, whereas in the B part, I have two root functions. So let's do the root function first, because it's like a little bit less work. Now, first thing I am doing is finding the domain of f and domain of g, because remember, f plus g, f minus g, and f times g. Actually, of course, we need that for the common function piece or common domain. We need it for the f over g as well. So we need to find the common domain. So our first function f of x is square root of 16 minus x squared. So what do? I pick up 16 minus x squared. Here I have it, greater than or equal to 0. What do I do next? I factor. So I have 4 minus x into 4 plus x is greater than or equal to 0. And now what do? After this step, we make a sign chart. With by putting the values, the zeros and the bad numbers on a number line. Well, we don't have the bad numbers there, just zeros. We have 4 and negative 4. I put them on the number line, and now I'm making a sign chart. When I make the sign chart for this quantity, I'm writing it that it will be negative in this region, negative infinity to negative 4. It will also be negative when on the interval 4 to infinity. We want to see where it is positive, because that's what we have here. greater than or equal to 0, positive or 0. We say it will be positive when it is between x is between -4 and 4, and it will be equal to 0 when x is equal to -4 or equal to 4. Therefore, the domain of f is, so the domain of f right here, dom f will be equal to -4 to 4, including this number. Now, in order to find the common domain, I will put these are number line together. So I can make a number line like this, -4, 4. But now I also want to put the domain of g on this line. So previously, this was our domain for f of x. And -2 will be somewhere to the right of the -4. So it will be, let's say, somewhere here, negative. So the g function has the domain starting at -2 and going all the way to infinity. So where is the overlap happening? Can you see it is happening right here between -2 and 4? So we say that is the domain. Okay. So the domain of the common domain is -2. So do we put a square bracket or do we put a parenthesis around -2? Can we have -2 and as a value and not get a 0 at the bottom? When we are doing, so remember, for the g function, we won't have the, so when we overlap, the -2 is also in function f. So the common domain will be starting at -2 and going up to 4 and not including 4. So that is the domain, common domain, which means that will be the domain for f plus g, f minus g, and f g. Okay, so 4 can be included, sorry. Why? Because it's just that we don't want it to be negative, right? It can be 0, so 4, it can take on the value 4. So -2, 4, that is the domain of the -2, 4, that is the common domain. So that is the domain of f plus g, f minus g, and f times g. What about f over g? Well, if you look at f over g, which is over here, can you see the denominator tells us that x cannot be equal to -2. So is -2 inside this domain? Yes, it is. So it means we have to throw that away. So the domain of f over g will be this one. So this is the domain for f plus g, f minus g, f g, and the one over here in which we just throw away 2 and everything else is there is called will be the domain of your f over g. Now, when we have fractions, both functions are fraction or rational functions. So we will have to add and subtract and multiply and all that. So looking at the domains first, so the f of x is given to be 2 over x plus 1 and g of x is given to be x over x plus 2. So the domain of f we can see is that we just need to throw away -1, and then this is the domain of f. And then we have domain of g. So at the bottom, the g cannot have the value -2, so we have to throw away -2, and that is the domain of. Now, if you put on the same number line, we have -2, and then we have a -1. So both have to be thrown away. So we have circle, circle. The rest of the domain or rest of the line, what is left is -∞ to -2. Here I have done it here. So this is the domain of f, and this is the domain of g. So this is the first, and this is the second. And now we combine them. We put them on one number line. So it means the common domain will be -∞ to -2, union -2 to -1, union -1 to infinity. What about f over g? So you can add and simplify. F over x over g of x will be just the first fraction, rational function, divided by the second rational function, and you know how division works. So it flips and gives us two times x plus 1, x plus 2 over x times x plus 1. So now in something, so we cannot have -1, which is okay, but this is also telling us that. But where did we get that? It is from the given, from the original function, that in g, because its bottom will become undefined, so we cannot have -2, -1, 2 in there, and then because of f we can have -1. So now we see that there is another number we cannot have, which is 0. So because of this x, so x cannot be 0, so it means we have to now throw away the x. So from the already existing domain here, we will have to throw away 2, and 0, and 0 is coming in the last interval, so it will split into 2 intervals. So down here, I have done that. So first 2 intervals are exactly the same as in the domain here. Comparing this one down here to the one up here. The first 2 intervals are same. The last interval over here, -1 to infinity, it splits into 2 intervals, -1 to 0, union 0 to infinity. So this is how we find the functions and domain and their domains. Next thing is asking you to evaluate these functions. So now if you have to find f plus g of 4, one way is to find f plus g function and then plug in 4. And but if I mean, you don't have to do it that, you can just apply the definition that f plus g of 4 will mean that it is equal to f of 4 plus g of 4. What is f of 4? I have done it on the side here. F of 4 will be 2 over 5. So remember it was x plus 1. 2 over x plus 1. So x is 4, so we get 2 over 5. And then g of 4 gives us 4 over 6, because g of 4 was x over x plus 2. So when you plug in 4, 4 over 6, which is same as 2 over 3. Now when we come here, so f plus g of 4 will be f of 4, which came out to be 2 over 5, plus g of 4, which came out to be 2 over 3. Common denominator fix the numerator, and we get the result 16 over 15. In the same way, we can find f minus g of 4. So f for 4 minus g of 4, and then subtract the two fractions that we have, and we end up getting negative 4 over 15. Then f times g, so you can see f of 4 times g of 4, so 2 over 5 times 2 over 3, which is going to be 4 over 15. Then we have f over g of 4. So f over g of 4, so now we find the fractions which we have already. Then we arrange them such that we have one fraction divided by the second fraction. So which fraction goes up on the numerator? The last one. So the first fraction goes in the numerator, which is 2 plus 5, 2 over 5, and the second fraction, which is 2 over 3, goes in the denominator. So then change the division sign into multiplication sign, and we end up getting the result 3 over 5. So this is how you do the addition, subtraction, multiplication of the functions, and then evaluating the function. So this is kind of part A of 2.7, and you should be able to do the homework 2.7a, and the next portion of this section in the next video.